All right, we're going to be going over the chapter 6 review. I'm going to go ahead and go through each of these problems and solve them here. This might take multiple parts. We'll see how it goes. All right, so here we go. We have first problem, some polygon angle problems, some regular polygon angle problems. So quick reminder, when we say regular, we mean that all the sides and all of the angles are congruent. They're all the same. Okay, let's go ahead and go through this. A says, what is the measure of each interior angle of a regular decagon? So decagon means that we have 10 sides. 10 sides. So we're trying to figure out each of the 10 angles, right? If a decagon has 10 sides, it's also going to have 10 angles. What each of those angles would be in a regular decagon. So we're going to make use of the polygon angle sum formula. So 10 minus 2 times 180, which is the same thing as 8 times 180. 8 times 180. That gives us a sum of 1,440 degrees. So all of the angles will add up to 1,440. We take that, divide by 10, because there's 10 angles that are all equal. And that's going to tell us what the individual angles are. And so that gives us that each angle is 144 degrees. Pretty simple. All right, next one, part B. What is the measure of each exterior angle of a regular pentagon? Pentagon, remember, 5 sides. Remember exterior angles. So if we're talking about a pentagon, let's just kind of sketch a random pentagon here. Try to make it regular. It's not great. When we say regular, we mean to take the side of the pentagon and to extend it. So if we do that for each side, we get all of the exterior angles. And so the thing to remember about the exterior angles is they are supplementary to the interior angles. So if you know the angle on the inside, the angle on the outside is supplementary to it because they make a linear pair. But also, no matter how many sides, the sum will always be 360. So that's actually a really great property. So the sum is going to equal 360 degrees. So in this case, if we have a pentagon, there are going to be 5 exterior angles here, just like there are 5 interior angles. So we take our sum, divide by 5. So 360 divided by 5, 72 degrees. So each exterior angle will be 72. We could actually take that and use it to find the interior angle as well. Supplementary to that, it would be 108. So anyway, that's our answer for this one. But again, remember that would mean that the interior would equal 108 because together these have to be supplementary because they make a straight line. All right. Last one here for question number 1. The interior angle of a regular polygon measures 150. So this is the interior angle. How many sides does this polygon have? Well, we could take an approach like A and kind of guess and check. Using this information, knowing that 10-sided shape gives us 144 degree interior angles, we know that it's actually going to take more sides. So we could kind of work our way up from a 10-sided figure until we got this sum. But that's kind of inefficient. It's a guess and check method, and maybe you don't even have a good starting point to start your guesses. So the best way to do it is, again, to remember that relationship between the interior angle and the exterior. So if you have your interior angle of 150, we don't know how many sides this has, right? This has some number of sides here to complete this shape. We know that means the exterior angle is going to be 30. So of this same polygon, the exterior angles are 30. And we know that all of the exterior angles will be the same because it is a regular polygon. Therefore, how many 30-degree angles does it take to get a total sum of 360, right? Because that's the exterior angle sum. So if we take 360 degrees, divide it by the one exterior angle we know, that's going to tell us how many there are. And so in this case, we figure out that there's 12. So this would be a 12-sided shape. And we could go ahead and confirm that, just make sure that we can do that. So 12 minus 2 times 180, that's 10 times 180. We get a total sum of 1,800. Divide that by 12, divided by 12. that does give us 150 degrees each. So that does check out. So we were looking for a 12-sided shape, which we would call a dodecagon. Dodecagon. I think I spelled it right. All right, let's go ahead and move on to the next set, question 2. So question 2, we're dealing with the angles of polygons, again, mixtures of interior and exterior. Here we have a hexagon, right? 1, 2, 3, 4, 5, 6 sides. We need to solve for x and y. So x, those are only involved in my interior angles, and then y is only involved with this one exterior angle. So really quick, if you don't have it memorized, you need to find your angle sum, interior angle sum for a hexagon. So 6 minus 2 times 180. That's going to give you an interior angle sum of 720. So you know all these inside angles are going to equal 720 together. And so you take that and you write an equation. 5x plus 4x plus 12 plus right? You want to write those all out and get your total angle sum. Sorry, guys. So I'm going to combine some like terms here, just kind of speed this process up a little bit. You can see the full equation on the answer key if you want to see that there. But combining all my like terms, the x's here. I am going to get 20x, and then combining all the like terms of the constants, I am going to get plus 10. And that equals 720. So again, I took all of these angles and added them together, and I got 20x plus 10 after the simplifying. All right, so subtract 10. We get 20x equals 710. Sorry about that. Divide by 20. And we get x equals 35.5. So 710 divided by 20. Yep, 35.5. So that's our value for x. And then we need to figure out y. So not the word y, but the value of y. So we go ahead and take the value of x here. These two angles are going to be supplementary, so we can figure out what this angle is and then use that to find the exterior angle. So this one's going to be 3 times 35.5 plus 5. That is going to equal 111.5 degrees. Supplementary to that, so we do 180 minus 111.5. Use my calculator here. Figure out that I have a 68.5 degree angle on this side. Those are supplementary together. And then I can write a little equation involving these values here. So 2y equals 68.5, divide by 2. I find that y equals 34 and a quarter, 34.25. These problems here, the answers do not end up being super nice values, so that's okay. We'll just go ahead with it. All right, let's go ahead and keep moving forward to our next problem, problem B for 2. So these again are some interior and exterior angles. We got a lot of different things going on. This one's actually probably a little easier than the last one. We have a 90-degree angle here. These are marked the same, so these are both x plus 14. This one here we can figure out knowing the exterior angle is 64. So if we do 180 minus 64, that's going to give us our interior angle here. So that's 120, 116. So we have a 116-degree angle on the inside. And in this problem, we are dealing with a 1, 2, 3, 4, 5-sided shape, so a pentagon. Again, if you don't remember what the interior angle sum for a pentagon is, you can go back to your formula, n minus 2 times 180. It's going to give you an angle sum of 540 degrees. So all 5 of these angles are going to add up to 540. I'm going to just go ahead and add these. This one's not so bad. So x plus 14 plus 116 plus x plus 90. It's important to just make sure you did get all 5 angles here. 1, 2, 3, 4, 5. We did get all of the 5 angles. It's easy when you have a lot of angles to kind of leave one out sometimes. I didn't do that on the last one because, yeah, I just didn't, but worthwhile to check it out, especially on the test, right? Okay, combining like terms, we get 3x plus 220 equals 540. We subtract 220 on both sides. We're going to get 3x equals 320. And then we divide by 3. And unfortunately, this one is not evenly divisible. We get 106.6 repeating, or 106.66667. We could, leave this as a fraction or whatever, but I'm just going to go ahead and write this out. That's what I have on my answer key. All right, moving forward to question C. On this one, just kind of taking a look at it, we know some specific angle measurements here. We can use kind of the interior-exterior relationship to figure out some of these. So like these are going to be a linear pair, so 80 and 100. Right here, this one, 95 and 85 are supplementary. Yeah. Let's see. Kind of filling the rest of these out, a little bit trickier. Let's see, 180 minus 53. That's going to be 130, 127. So this one's 127. 180 minus 62. That's 120, 118. So we got 118 here. And then as we have a couple options for figuring out Z. We could use our exterior angles. We're missing one exterior angle and kind of do that, and then it's supplementary to it. We know all but Z on the inside, so we could do that. Kind of our options here. Since this is another pentagon like the last one, let's just go with that method. So we have 100 plus 118 plus 95 plus 127 plus Z. And that is going to equal 540 degrees. Ran out of space on the right, so I went ahead and put that there. Okay, let's simplify this so the left side remains unchanged. Let's combine all those like terms over there. We get 440 plus Z, and then subtract 440 on both sides, and we get the value of Z to be 100. Z is 100. So Y is 100, Z is 100, X is 85. All right, let's keep moving forward. And here, this one's probably one of the trickier ones. A lot of variables going on. It's not super obvious which way to go. Just taking a look at it, we have a quadrilateral. There are 4 sides here. This is almost looks like a trapezoid, but these aren't quite parallels, but it is a 4-sided shape. So remember 4 minus 2 times 180. We know the interior angles need to add up to 360. That's worth thinking about. But the interior angles, when I look at them here, they're kind of all different variables, right? We got a W, we got a Z, we got a Y, all kinds of different variables here. So the interior angles aren't really going to work for us. But when we look at the exterior angles, all of those are in terms of X. And remember, the exterior angles of all polygons, exterior angle sum, will always be 360. It does not matter how many sides it has. It could be a triangle, a quadrilateral, a pentagon, a hexagon, an octagon, whatever, 100gon. Always going to add up to 360. It's a very useful property. We're going to make use of it here. So these 4 angles will need to add together to equal 360. So solve this one. 6x plus 9. It's this one. Plus 7x minus 35 plus 8x minus 5 plus 9x plus 1. And that's going to equal 360. And now I wrote this equation weird. I just kind of ran out of space. So I've got x, 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 x. That's 15, 22, 30. 30x. And negative 40 and positive 10, that's going to be minus 30. Equals 360. Okay, going ahead and solving this, I got to add 30 on both sides. And I got 3x equals 390 divided by 3. We find that x equals 13. Lucky number 13. So x is 13. Now we got to take this and kind of find out the rest of these values here. Kind of do it in whatever order we really want. Let's go ahead and start with y, because why not? So I want to find this exterior angle here, use the supplementary relationship to find the interior angle. So 6 times 13 plus 9, 6 times 13 plus 9 is 87. So 87 and 93. So this angle here is a 93-degree angle. That can allow us to solve for y. 2y equals 93. Divide by 2. I get that y equals 46.5, right? Yeah. Okay. Moving forward, let's go ahead and find w next. So w is here. This angle would be 8 times 13 minus 5. 8 times 13 minus 5. It's 99. So that's a 99-degree angle. That means that this one here is going to be 81. So w minus 10 equals 81. Add 10 to both sides, we get w equals 91. Okay, moving forward, the last one to figure out here is z. So let's find this angle, 9 times 13 plus 1. 9 times 13 plus 1. That's 118. That makes this angle 62 right here. So that gives us an equation. I'm going to write it up here. 3z equals 62. Divide by 3. I get z equals something that's not super nice, I think. Yep, that's 20.6 repeating. All right, so not super wonderful answers here, but there we go, got them. Found w, x, y, and z. That is something, pay careful attention to what you're asked to actually give as your final answer on the test, okay? Okay, next one here. All right, we're gonna move into some parallelogram properties. So want to remember what those are. I'm just gonna kind of make a quick list here of parallelogram properties. So defining characteristic, opposite sides are parallel. What's another parallelogram property? The opposite sides are congruent. Opposite angles are congruent. We got diagonals bisect each other. We got one more. It is the consecutive angles are supplementary. So these are our parallelogram properties. Just useful to remember them, you know, which one we might use for a particular problem. In this case, we're going to be making use of, what is this one? The fourth one, diagonals bisect each other. Okay, so that means that each of these diagonals, so from here to here, I'm kind of coloring that one blue, and then this one here, let's just do yellow. Maybe it'll stand out a little better. There we go. Those are cut in half. They meet at their midpoints. A little more marking. That means that this piece here and this piece here are equal, and then these two are equal as well. Well, we're looking for the values of A and B. We want to see what we can solve. I'm looking at this one. The reason I'm looking at this one is because these expressions both have B in it. When I look at the other one, even though they are equal, I would have B and A in my equation. I'd have two variables, so I'm going to have to use these two. So 5b minus 7 equals 3b plus 6. I'm going to be subtracting 3b from both sides. Getting 2b minus 7 equals 6. Add 7 here. I get 2b equals 13. Divide by 2, and that is 6.5. 6.5. So that's the value of b. We also want to solve for a, so we can use this to help us out. If I substitute that in, if I substitute it in 6.5 here, that's 3 times 6.5 minus 5. Calculator in front of me. 3 times 6.5 minus 5. That is 14 and a half. And that is going to be equal to 2a, equals 2a. Pretty easy equation now. Divide by 2, divide by 2, I get 7.25 equals a. Again, you may have to solve for them in a certain order in order to make it work. In this case, we did have to solve for b first to make this one work well for us. All right, let me see if I can copy this so I can keep this in mind. Okay, so on the next one, let's go ahead. Yep, it's right there, perfect. So here's our properties. Let's go ahead and take a look at what may be useful. So opposite sides are parallel, so that means that these are parallel. And these are parallel. Not super important, but good to know. The opposite sides are congruent. That means this one, and these two are congruent. That gives us a situation, right? That tells us right here, these things have to be equal to each other because the opposite sides are congruent. So this allows us to be able to solve for z. I should say that I'm solving for the variables here. I'm just sort of assuming that I do need to know these different variables in order to evaluate them. And so in order to figure out the length of jk, I do actually need to figure out what z is. I'll need to plug it in right there. So same way for these other things. For jl, I'll need to know what y is, so I can use that. And for mn, I'll need to know what x is to use it. Okay. All right, get all of our z's on one side. So I'm going to subtract 8z on both sides. That gives me 8z minus 4 equals 4. Add 4. I'm getting 8z equals 8. And then divide by 8, I get z equals 1. Okay, z equals 1. That's useful. That means that jk, I can just plug in 1 here for z. 16 times 1 minus 4. That's 16 minus 4. That means that jk is going to equal 12. That's our first answer. Let's go ahead and solve for one of these other things. Looks like, again, the other property I'm going to be using here is that the diagonals bisect each other. So these pieces are equal, and these pieces are equal. Doesn't really matter which one I do next. Let's just go for the y's next, because why not? So 4y equals 3y plus 2. Subtract 3y on both sides, and I get y equals 2. Pretty easy there. Y equals 2. Now to find the length of JL, which is all the way from here to here, I could find both of these and add them together, but I could also just find one of them and double it since they're equal. So I'm going to go ahead and use this expression and just double it. So JL is going to equal 2 times 4 times 2, 4y, which is 8. 2 times 8, JL is 16. A couple options there for finding that. That's the one I went with here. I think I did something different on the review answer key, but it doesn't matter. All right, and then the last one, we need to find mn, so we need to know the value of x. We know these two pieces are equal, the halves of the diagonal, so 2x minus 2 equals x plus 6. Let's subtract x on both sides. That is going to give us x minus 2 equals 6. Add 2, and we get x equals 8. Great. X equals 8, and from there, we want to find mn. So we're going to use 2x minus 2 for that. Mn equals 2 times 8 minus 2. That's 16 minus 2. MN equals 14. And those are our three answers, I believe. Yeah, we found JK, we found JL, we found MN. Awesome. All right, and then I'm going to do this last one, and I'm going to cut this for part one. Okay, so again, let's just paste that on there just to keep in mind our different properties. So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other. For once, we're not going to use anything with diagonals here. We don't have any drawn. Well, we will make use of that third one right here. Opposite angles are congruent. That means that these angles are congruent and these angles are congruent. That is useful to us because we do want to find the measure of h. So we can find k and h will be the same. And also this lets us solve for m right here because these two are going to be the same as each other. They are opposite, they're across the parallelogram from each other. So let's do that to find m. The reason I'm doing this is because I don't see any way for us to directly solve for n, which seems to be the one we really want. So let's solve for m so we can get some more information about this parallelogram. 2m plus 31 equals 7m minus 29. I'm going to get all my m's on one side. So I'm going to subtract 2m. And then I'm going to go ahead and add 29. I'm just going to condense this down a little bit and just do two steps in one. So that's 60 equals 5m. Divide by 5. I get m equals 12. Okay, great. That wasn't something I needed to find for the answer, but I did need to find it for this process. So now we can use that to find the measure of this angle. 7 times 12 minus 29. So I found that this was 55 degrees. Again, that's useful because this final property down here, the consecutive angles are supplementary. So if this one is 55, that means k is going to be supplementary to it, and h is going to be supplementary to it. So 180 minus 55 gives us 125 for this, which is the same as k. So that's one of our answers. Measure of angle h is equal to 125. And then find the value of n. Well, I just need to set this. This needs to equal 125. So 12n plus 11 equals 125. Subtract 11. I get 12n equals 114. Divide by 12. And 114 divided by 12. So that's 9.5. All right, so we found both of our answers there, kind of using some of the angle properties. I'm going to go ahead and cut this right here, and I'll see you in part two.